Hey everybody, thanks for joining us again on the channel. I apologize for the break last week, but unfortunately I had to say goodbye to my kitty that I've had for almost 18 years. And unfortunately she took a turn and she's not with us anymore. But hopefully she's off playing with all of my past doggies. So anyway, we're back to it. This week we're going to do drill and driver, just some examples. I know this first stuff is a little bit dry. Hopefully after this we're going to get into some more interesting projects now that we have a little bit better feel for the tools that we're starting to use here. I know for a lot of people watching it might be a big review. I apologize for that, but we're going to start at the beginning and let's get into it. Okay, so we're going to get started with our twist bits. It's a split point bit. This is good for wood and steel. I'm going to run it on high speed as I'm drilling into the wood here. Now this is a different type of twist bit. This one's got it's a step point, or I think it's called a bullet point by DeWalt. This bit will drill a little differently. It starts with a small hole for the tip, and then the step will drill the actual outside diameter of the drill. That one will work for wood and for metal as well. Now we're going to look at the brad point bit. Now this one's only for wood. This has some spurs on the outside and a sharp center, so that point keeps it centered. The spurs cut the outside of the diameter of the cut, and usually that'll keep it cleaner. Typically you're using this bit for maybe putting dowels in. You might be plugging this hole, so you want a cleaner hole because you might want to sand it and finish it. So that's going to make a little cleaner hole than that split point bit. And even the bullet point will leave a little bit cleaner hole. Now this is a paddle bit or a spade bit. This one's got little spurs on the outside as well. Some have the little chamfered corners, and I don't think they give as clean a hole. Sometimes that's not important. This bit might be used for putting bigger dowels in, or maybe used by plumbers, electricians for running wires, or small plumbing lines. These bits will come in a variety of sizes. I usually only use it down to about a 1/2 inch. They'll go all the way up to maybe 1.5 inches. And the wider bits are just a little bit tougher to drill with because they only have 2 points. This is a Forstner bit. That's 1 3/8 inches. This is something that's sized for European recessed cabinet hinges. Normally you'd use it in a drill press. This one's really sharp and it's easy to drill with my drill, but the idea with the drill press is you would keep it very square to the work. And you're trying to go to a specific depth. Craig makes a jig that sits on there and keeps it stable and keeps it square to the work. That's another option besides using the drill press. This is an auger bit. This is a 1 inch. I don't know if it's a ship auger. I'm not exactly sure what qualifies it as a ship auger, but the tip on this will help feed the bit into the work. This bit only has one cutting tooth, so it's a little bit rougher cut. This is something you'd use for drilling through thicker material like big timbers or maybe stud packs. I'm going to use the handle to help with the counter rotation. When this thing starts to drill, it's going to want to spin in the opposite direction, and it will twist on you, so you need to hold on. Got it in high gear here. Let's turn it down to low gear. And you can see those chips want to come up and out through the flute, so if you're drilling a long hole, it helps get that debris out. And it's going to be for drilling through longer stud packs and things like that. That tip is what helps pull it into the wood. And you can actually find some of those Forstner bits with that tip as well. It's like a self-feeding tip, and it helps pull the drill bit into the work. Here's our friend the hole saw. This is a 3-inch hole saw, 1/4-inch pilot bit with a removable mandrel on it. That way you can take a different size hole saw and put it on the same mandrel. This one uses the handle too. There's going to be a lot of torque. The bigger the hole saw, the more counter rotational torque you're going to feel when you try to drill with it. So you want to hang on to it. You want your work clamp down, and you want to have a good steady hand on it because it'll jump on you. And it's also important to lift the hole saw up occasionally and get the debris out, because the teeth are really small and there really is no way for them to be ejected from the hole as you're drilling it until you get the plug out. And there's your plug. So in order to get the plug out of there, you can use a screwdriver, you can use a punch, or anything that you can get into this hole to kind of pry on it will help you remove that block. And be careful, because typically those hole saws will be hot when you're done drilling with them. Now, if you want to clean up that hole, if you were doing this on a nicer piece of work, there's a drum sander. That's a locking nut, and when you turn the nut counterclockwise, it expands the rubber and locks that sandpaper on there. Now, this would be sort of used as a detail sander. They make different diameters. They make it down to 3/4 of an inch, I think. And this is just a freehand version. You can put this on a drill press as well, but you can go around and clean up the inside of a curve. High speed's probably better on this. And you can go around the inside, clean that hole up. You could go in a smaller hole if you had a smaller diameter sander, and you can do it on the outside of the material too. Now let's look at attaching two boards. If I'm going to attach a board with a screw, and say I'm screwing this down, but it's a small piece or it's right near the end, it's likely to split. So in order to prevent the splitting, we'll pre-drill a hole. That's where the countersink comes into play. Ta-da! Okay, so this countersink is sized to work with the screw and the plug cutter we're going to use in a minute. So we pre-drill, and if you just want the screw to go in and sit flush, and you're not worried about hiding the screw, you stop at the tapered part of the countersink, and you don't drill any deeper, and then you get the appropriate driver. This is a 25. Actually, I think I have a 25 drive in my driver already. It's colored green. That's the color coding for the torch series of bits. And you can drive this screw in, and because there's a hole already that's a little smaller than the threads still bite. The head goes flush, and I didn't split the board out. And the key to this countersink is you can do that flush mount, or you can also create a hole and a countersink to set a wooden plug into. So first, you want to drill the countersink violently in this piece of wood. Just kidding. Be gentle. Now you're going to keep drilling past the tapered part, but you don't want to really bottom out on the collar because it will burn a ring in the wood. And that is smoking hot. Don't touch that with your tongue. That's the plug cutter, excuse me. And that's one style. They make different styles. This typically works better in a drill press, but we're not going to get into the drill press at this moment. Right now, I've got a cheat where I have a piece of plywood with a hole the size of the plug cutter. So if I take this plywood and use it as a guide, I can take it and set it on this piece of wood, which I think this is just a scrap I grabbed. I believe this is hickory, which is a pretty hard wood. And you can see it has some pretty pronounced grain lines in it when you're looking at that board. Normally, I would try to pick a spot where I get a really good grain match and I could make this plug try to go away. But for this example, I'm not really being that particular. So we get the hole started using our guide. Then to get all the way through, the guide makes it a little too deep. So we get the guide out of the way. And then keep your board clamped down. And what you're going to want to do is make sure that your plug cutter is tightened into the drill, which it is not currently, so I'm going to tighten that down. Now, if you keep drilling and that material's thin enough, the plug cutter will go through and it'll pop that plug loose. Now you grab a little screw or something to get that loose. And there you go. Now you've got a plug that's cross-grained, by the way. So when you put it in, the grain will line up with the grain. If you put a dowel in, you're going to see the end grain and it won't match. So with this, we can get a little glue on here. Maybe. And there we go. Suspense was killing me. Okay, and you can put glue on the inside of the hole also, which helps keep it from squeezing out around the outside. Trying to line that grain up so that when you cut this all off, it's as invisible as it can be. Set it in there till it's snug. Normally I'd let the glue set up a little bit, and I will scrape the glue away usually as opposed to using a wet rag. The wet rag sometimes will thin the glue out and then it fills all the pores around and it makes the finish go in kind of funny. So now we'll take a chisel, and I like to sneak up on this. If you try to be too aggressive knocking this plug off, the grain can tear out below the surface and then it looks ugly and you have to start over. So try to do it gradually, shave it down, and once we get it nice and close to flush, we can finish it out with some sandpaper and it'll be ready for finishing. And it'll be a lot less obvious than seeing that big screw head sitting there. Look at that. Beauty. And we'll try to get that grain lined up better next time.
Okay, so there you have a brief breakdown of the drill and driver, some sample bits. We really didn't get too deep into it. We'll dive into the minutia of stuff later on as we get into specific projects. Hopefully we can find some fun stuff to work on. If you have anything you'd like to see, put it in the comments. As always, like and subscribe. It helps the channel. And I hope you can join us again next time. Take care.